Four corners. Light and shade. Susanna Daniel. Light and shade. Light is vitally important to our planet. Think about how often you use light. Maybe you turn on a light to get dressed, use sunlight to locate your bike outside, or click on a torch to find your socks under the bed. Light is important for reasons other than seeing things. Without light, most living things could not survive. Plants need light to grow. They absorb light and use it to make food. Light from the sun is the main source of heat and other forms of energy on Earth's surface. Sunlight also plays a major role in the changing seasons and the illumination of the moon and planets. Most animals and plants that live underwater need sunlight to survive. Some of our sources of light are natural, such as sunlight. Others are artificial, such as electric lamps. However, all light has the same characteristics. Knowing what these characteristics are can help you predict how light will behave. It can also help you understand the role light plays in shaping the world. The activities in this book can help you understand about light and how it can be manipulated in the creation of optical devices, such as a camera and a periscope. You can also observe the role of the sun's light in shaping the cycles of day and night and the seasons, and in illuminating the moon's surface. Before you begin each activity, gather all the materials you will need. Then use the photographs to help you follow the instructions. If you see this symbol, please ask an adult to help you. Take your time working through each experiment, and have fun. An electric lamp produces artificial light. The behavior of light. Light is a form of energy. When we talk about the behavior of light, we are talking about the way in which it travels and how it interacts with matter. For example, light behaves differently when it strikes a transparent object than it does when it strikes an opaque object. It will pass through the transparent object, but it cannot pass through the opaque object. Light can be bent as it passes from air into water or glass, or it can be reflected, bouncing off the object it strikes. The activities in this chapter will show you some of the ways in which light behaves. Directing light. You and a friend can direct light to see how it behaves as it travels. Materials. Scissors. Cardboard. A hole punch. A narrow beam torch. Procedure. 1. Cut 3 identical squares of cardboard. Then use the hole punch to make a hole in the center of each square. 2. Line up the 3 squares so that the light from the torch shines through all 3 holes. You may need a friend to help you hold the squares straight. 3. Move any square to one side or the other. Watch what happens to the light. The sun's rays show how light travels in a straight line. Transparent, translucent, and opaque. These photographs show how light behaves when it hits materials that are transparent, translucent, and opaque. The orange arrows represent light rays. 1. The rays go through the transparent material. 2. Some of the light passes through the translucent material, but some bounces off the surface of the material and scatters. 3. Light rays cannot pass through opaque material. Look and discover. What happened when you moved one of the cardboard squares? Cardboard is opaque, and light cannot pass through it. However, light can pass through a hole. When the holes in the cardboard squares were lined up, light from the torch passed through them all. When one of the squares was moved, the light was blocked. This experiment shows that light beams travel in straight lines, called rays. Reflecting light. Sometimes light rays bounce off materials that they encounter. This is called reflection. The angle at which the light hits a reflective surface affects both the way it bounces and how much it bounces. See for yourself how angles affect reflection. Materials. A shallow black pan. Water. A torch. Procedure. 1. Fill the black pan almost to the brim with water. 2. Darken the room. Then turn on the torch and hold it above the water so the light hits the water surface from directly above. 3. Shine the torch at a low angle across the water surface. How reflection works. If you drop a ball straight down, it hits the ground and bounces straight back up. If you throw it at an angle, it bounces away at the same angle. Light rays work in the same way. Light rays are reflected from a surface at the same angle at which they hit the surface. Light from the torch bounces off a mirror. Light is reflected straight back. Look and discover. What happened when you directed the torch beam directly above the surface of the water? Did the water seem very dark? How much light was reflected back into the room? Compare that to what happened when you shone the torch at a low angle. How much light was reflected into the room? Which torch position reflected more light into the room? When light strikes water from directly above, the water seems very dark. The light passes through the surface of the water and falls onto the base of the pan. However, when light hits water at a low angle, some is reflected back into the room. Refracting light. When light rays pass from one transparent substance to another, they change direction. This is called refraction. This activity will help you explore how light refracts. Materials. A cardboard shoebox. A pen. A ruler. Scissors. A sheet of white paper. A glass jar. Water. A torch. Ask an adult to help you with step 2. Procedure. 1. Draw 2 vertical lines, about 2.5 centimeters apart, down the middle of one short end of the shoebox. 2. Cut narrow slits along both lines with the scissors, leaving at least 2.5 centimeters uncut at the top and at the bottom. 3. Cut a white sheet of paper so that it fits in the shoebox. Place the paper in the bottom of the box so that it lies flat. 4. Fill the jar with water and set it carefully in the box. Line it up with the 2 slits. 5. Darken the room. Then shine the torch through the 2 slits in the box. 2 beams of light come through the slits in the box. Look and discover. Does each ray continue in a straight line inside the jar? Where do the light rays first change direction? Do the rays bend again as they leave the jar? Light passes through different substances at different speeds. When the light rays go from air into water, they slow down and refract, or change direction. The rays bend again as they leave the jar. The light is very bright where the rays cross. Making a rainbow. White light, including sunlight, is actually made up of a rainbow of colored light. Create your own rainbow to see for yourself. Materials. A shallow glass baking dish. A hand mirror. Modeling clay. Water. A torch. A large sheet of white cardboard. A prism separates white light into different wavelengths, so all the colors of the visible spectrum can be seen. Rainbows. Why do you sometimes see a rainbow during a rain shower? Raindrops act like tiny prisms. Light with longer wavelengths, such as red, is refracted less than light with shorter wavelengths, such as blue. As sunlight is refracted, the colors that make up the light are separated. Procedure. 1. Place the mirror in the dish at an angle of about 45 degrees. Use modeling clay to secure it so it does not slip. Fill the dish halfway with water. 2. Shine the torch onto the section of the mirror that is under the water. A rainbow